All right, so today we're going to look at our last two quadrilateral, specific quadrilaterals that we're going to kind of dive into their properties. So both of these aren't parallelograms, right? But they're still quadrilaterals and they still have some interesting properties to look at. So the first thing we're going to talk about is a trapezoid, right? So a trapezoid has one pair of parallel sides and two pairs of what we call base angles. Right, so if I look at this kind of trapezoid diagram over here, right, I have the parallel sides, right? So these are these red sides that I'm going to kind of highlight. Those are what I call my base, right? My bases. So I have the top base, bottom base, and so those are what then make these base angles, right? I have two pairs of base angles. So the two pairs at the top and the pair at the bottom. And then I have the other sides, the sides that connect the bases, right? We call these the legs. These are not parallel, right? They would intersect if we were to extend it. But those are the legs of my trapezoid. We do have one kind of, once I kind of dive in and get a little more specific, something happens when the legs are congruent. And so when I have a trapezoid with congruent legs, that's what I'm going to call an isosceles trapezoid, right? Still a trapezoid, still has the bases, still has the base angles. Now the only thing we notice is that the legs here are congruent. So isosceles trapezoids have some properties that are unique to it being isosceles, right? And so one of the first things, and these are the types of trapezoids we're really going to focus on for kind of our properties and what we look at. So first thing is that if I have an isosceles trapezoid, each pair of base angles are going to be congruent. Right, so if I were to kind of look here, right, this pair of base angles, these two are congruent, and this pair down here are congruent. So isosceles trapezoid, those base angles are congruent. The other thing I can look at is trapezoids still have diagonals, right, where we're connecting opposite vertices. So in an isosceles trapezoid, these diagonals are going to be congruent. So I'm going to use both of those kind of facts to help me solve some problems. So let's look at one example before we kind of dive into one more property of trapezoids. All right, so if you look here, right, basically I'm trying to find D, E, and F. So I want to know what are the other three angles. So if I look at this, one thing I notice is that, I have this trapezoid, but the big thing is I have an isosceles trapezoid, right? My legs are congruent. So that means the base angles are going to be congruent as well. And so when I look at this, right, I'm going to say, well, if this C and F are one pair of base angles, so I know then that the measure of angle F has to be congruent to the measure of angle C, so F has to be 65, right? So the question is, well, how do I then look at what are D and E, right? So if I kind of look up here and notice a couple of things, right? Because I have a trapezoid, I can say that, DE and CF are parallel, right? And then DC kind of acts like that transversal that we talked about in the last unit. So I need to look here and say, well, what kind of, pair do I have, right? Well, I have that same side interior angle. So if I go back to what's that relationship between same side interior? Well, I know they're supplementary, right? So it means that D and C have to add to 180. So if I were to look at that, right, I could say, well, the measure of angle D has to be whatever adds to 65 to get me to 180. So if I were to do 180 minus 65, I would get 115. Right? And then I know that because D and E are base angles, get 115 degrees because those two things have to be congruent. So now we're going to take a look at one more property of trapezoids, and just kind of trapezoids in general. And there's something that happens with something we call the mid segment. So first off, we have to figure out, what is the mid segment? So the mid segment is the segment that joins the midpoints of the legs. All right, so a couple things then we know, right? The mid segment, if I have a trapezoid, is going to be parallel to the two bases, right? And then there's something special that happens with the length. So the length is going to be half the sum, right, of the lengths of the bases. So we'll kind of write this into a formula. So the first thing we know, if I were to label this as M and N, right, I know that MN is parallel to RA, and MN is parallel to TP. So that's kind of that first part, right? Mid segments are parallel. Second part, we're going to write kind of a general form of an equation. So I know that the length of MN is equal to 1/2 times the sum of the bases. So we're talking about sum, right? We're talking about adding things together. So you'd say RA plus TP. So if I want to look at and say, well, let's kind of label what I have here, right? So just to kind of refresh, MN is the mid segment, right? And then RA and RP or TP are the bases. So I'm just going to use that kind of general form of my, my kind of general trapezoid to then use that to write an equation if I have to look at a problem for that. Right, so if I look at this example here, it says, what is X? So I look and I say, well, okay, I have a trapezoid, right? And these are midpoints as, labeled by the congruent symbols here. So I know I can kind of use my equation up here to fill in the values that they tell me, right? So the mid segment is kind of this QR, right? So look there, I know what X plus 2 is equal to 1/2 plus the lengths of my bases, right? And my two bases are this LM and PN. So I take my two bases, right? 4x minus 10, add it to my length of my other base, plus 8. And so now I just have an equation I can solve, right? So first off, I want to kind of look at combining like terms. So I know I have nothing alike out here, so keep all that the same. That 4x, if I were to do negative 10 plus 8, I would get negative 2. So next I want to distribute that 1/2, right? So I have x plus 2 equals 4x minus 1. And now I can just go about solving this, right? Minus x minus x. Sorry, made one mistake here, I just noticed. This should be 2x, right? Because 4 times 1/2 is 2. So if I do that, I have a 2 over here. X minus 1, add 1, add 1. X is equal to 3. Right? So once you set up that equation, it's just a matter of solving it and getting your answer. All right, so the last shape that we're going to look at is a kite. Right? So kites have two pairs of consecutive sides that are congruent. And no opposite sides are congruent. So there's one kind of property that I look at for kites, and that's that, once again, I have diagonals that are perpendicular. right? So a lot of times we look at stuff like this, we're kind of looking at finding missing angle measures in a kite, right? So if I look at this kite EDGF down here, right? They want to know what are the measures of these angles. So if I look, I notice that I have the diagonals. So angle 1 is really easy to find, right? If I know the diagonals are perpendicular, I just go back to what is the definition of perpendicular? Well, it means they meet at a 90-degree angle. So I know that 1 is 90 degrees. Now, if you notice, right, if I go to start to find angle 2, if I kind of highlight this where all those angles happen, I have a triangle. So I can use that fact from the last unit that we talked about, that triangles, their interior angle measures always add to 180. All right, I can use that fact because now I know that 1 is 52, 1 is 90. I can do 180 minus 90 minus 52 and get the angle measure of angle 2. So if I do that, I get that angle 2 is equal to 38 degrees. And so then I can look at, and when I want to try to find angle 3, there is something that happens with this, right? Because of kind of this angle also being 90 degrees, that those triangles, we haven't really talked about this, but those triangles are congruent. And so the angles up here, right? So 3 and this 52 are also going to be congruent. So those two angles are always going to be the same. And so I just want to turn your attention to your last page here. You're not going to take any real notes on this, but it is just kind of a summary of the relationships among all the quadrilaterals that we've talked about, right? So quadrilateral is kind of the very general name for any four-sided shape, right? I can have a quadrilateral and it can have no special properties, or it can have these ones that we've talked about, right? So if I look at, well, the ones with two pairs of parallel sides, right, we call those parallelograms. And then I have special kind of properties, right? I have rectangles and I have rhombuses, right? So each of those are both parallelograms and they have their own properties. And then kind of when I combine a rectangle and a rhombus, I get a square, right? So that's how those are related. When I talk about one pair of parallel sides, we just talked about today, right? I have a trapezoid, and then I have that kind of special case where the legs are congruent, and an isosceles trapezoid. And the last kind of special one that we talked about is this idea when I have no parallel sides, right? No pairs of them. I have a kite. So that's just kind of a general kind of where do things fit together. Important concept just to kind of remember.